Hello, and welcome to this energy efficiency presentation prepared by GRID 2020. We thank you for your interest in learning how GRID 2020 can help Ontario and global distribution providers around the world to optimize energy efficiency. Through its patented intragrid sensor solution, GRID 2020 provides utility operators with clear vision into the heart of the distribution grid. Throughout the last several years, Ontario has worked diligently to create a viable long-term energy program and has instituted the Conservation First framework as an integral element. Conservation and demand management plans have been administered by the IESO in part in Ontario, along with other bodies of participation. The new Conservation First framework is described as a conservation planning and management tool to be utilized in Ontario by the LDCs. Collectively, Ontario's LDCs are responsible for planning cost-effective ways to reduce up to 7 terawatt-hours of electricity consumption by 2020. The LDCs in Ontario are encouraged to work together or individually or in whatever manner they believe makes the most sense so that collectively they can achieve the Conservation First framework goals. In addition, funding opportunities have been presented to the LDCs to help them fund the investments they will make in an effort to address the Conservation First framework initiatives and therefore contribute toward the long-term energy program efforts of Ontario. For the purposes of this demonstration, the analogy of a bathtub will represent the distribution grid space. In this case, the spigot is designed to represent the substations or the injection point. The bathtub itself represents the distribution grid network, also known as the collection of power poles, power lines, and distribution transformer assets. And with every bathtub comes a drain where the water, of course, is to exit. And in the case of an electricity grid, that drain would be symbolized by meters, endpoint meters. In the case of Ontario, that would involve 100% automated meter infrastructure or AMI smart meter deployment. So ideally, water or electricity would enter the tub or the distribution grid and go out through the drain or the endpoint meter. Throughout the last several years, not only in Ontario but literally around various facets of the world, ratepayers have been encouraged to install LED bulbs and smart thermostats to help lower their rates, reduce demand pressures, and lower carbon footprint. Additionally, renewables such as solar rooftop or wind have been encouraged to be utilized by ratepayers to, again, reduce rates, reduce demand, and lower carbon footprint. And electric vehicles, which create an impact in the electricity grid, have also been encouraged and incentivized for the primary purpose of reducing carbon footprint in various communities. So in the case of Ontario in particular, LED bulbs, smart thermostats, renewables, electric vehicles, and smart meters collectively have been encouraged and incentivized at the grid edge to help reduce costs, to help lessen demand, and to help reduce carbon footprint in Ontario. The problem that we face is that the electricity grid is not a bathtub. If the electricity grid was a bathtub, we would be able to walk outside our doors, walk along the distribution grid of power lines, power poles, and transformers, and we would be able to see leaks that are occurring throughout the distribution grid. But as we all know, electricity is invisible, and therefore all of us, even utility personnel, are unable to identify where leaks are occurring within the distribution grid at any given time. In the case of Ontario, in the year 2015, according to the Ontario Energy Board data, which rolls up all of the LDC data into one report, $518.2 million of power loss leaked from Ontario's distribution grid. The $518.2 million, however, was a cost that was amortized across Ontarians, although it was not reflective of the energy that they had consumed. For each of us who pay our bills on a monthly basis, we certainly understand that the kilowatt hour is the standard unit of measure for electricity providers. It's the kilowatt hour that determines what our consumption is on a monthly or periodic basis, and it's also the kilowatt hour from which our monthly bills, if you will, are driven and derived. Therefore, it's obvious that the kilowatt hour is very important when it comes to the standards associated with pricing in the electricity industry. In the case of Ontario, also via the 2015 Ontario Energy Board data, it's revealed that 4.64 billion of these important kilowatt hours actually leaked from the distribution grid and were unmetered by the smart meters that are deployed throughout Ontario. So while collectively we've all been encouraged, rightfully so, to be installing LED bulbs, smart thermostats, renewables, electric vehicles being embraced, and smart meters being embraced, all with the concept collectively of reducing costs, reducing demand, improving conservation, and reducing carbon footprint, unfortunately, we still are experiencing tremendous leaks from within the distribution grid. So the real problem is actually energy inefficiency, and that inefficiency is actually inside the grid itself. The problem has been leaks are invisible, but now we're able to address that type of problem with emerging technology known as intragrid sensor solutions. So from every real problem stems the real opportunity. In Ontario's case, the real opportunity consists of several points. The first being the opportunity for Ontario to accelerate its energy conservation success. The opportunity to reduce generation by up to 2.3 terawatt hours per year. The opportunity to bend down the rate curve for Ontarians across time. The opportunity to reduce Ontario's carbon footprint, the opportunity to safely embrace renewables and electric vehicles, the opportunity to create the carbon emissions reduction credits, the opportunity to increase manufacturing jobs in Ontario where intragrid sensors are currently manufactured today, the opportunity to increase Ontario's HST revenues by the sale of intragrid sensors within Ontario and abroad, and collectively, the opportunity to create a world-leading smart grid in Ontario. In our opinion, the real solution is GRID 2020, where we help LDCs and utility operators around the world to optimize energy efficiency. In our effort to create a business case for Ontario, we accessed the 2015 Yearbook of Electricity Distributors prepared by the Ontario Energy Board. It's this information that consists of individual LDC information and also then a rolled up perspective of all LDC information as well. As we were working to build our business case, one of the most difficult questions that had arisen was what will it cost to remediate loss inside the distribution grid. So when we take all of this invisible loss, which was 4.64 billion kilowatt hours worth in 2015, and we begin to identify where those leaks are occurring, the key question is, great, what's that going to cost us to fix? Which is a fair question. There are really many variables that make it incredibly difficult to predict with tremendous accuracy what the remediation cost may be. But as we scoured the 2015 Ontario Energy Board Yearbook for electricity distributors, we were able to locate a piece of data that we think is extremely important. In this case, we focused on the entire grid maintenance expense in Ontario for 2015, which is represented on this slide from within the 2015 yearbook, was just in excess of $411 million. So what we did is applied all $411 million worth of entire province grid maintenance cost and considered that to be the amount of what remediation, installation and remediation costs, I should say, would equal. It's our personal opinion that $411 million exceeds, perhaps grossly exceeds, what the actual remediation costs will be, but we've utilized this real number of grid maintenance expense and applied it into our business case, as will be illustrated on a subsequent slide. The business case snapshot for Ontario. In this case, you'll see a lot of information listed on the left-hand side, which has been extracted from the 2015 Ontario Energy Board Yearbook Report, as previously mentioned. In addition to that information, there is information in here proprietary-wise relevant to GRID 2020 with regard to understanding of the association of transformers to meters and the percentages of single-phase versus polyphase transformers within the Ontario grid, of which there are some estimates presented in this business case snapshot, but the estimates themselves, we believe, are extremely realistic and really designed to kind of undersell the business case as opposed to present too aggressive or too overstated a position. So we are approaching this, in our opinion, from a very modest perspective when we're presenting our business case to you. To summarize the information on the left side, rather than read through each individual line, we'll approach it in this manner. We have the given that 100% AMI penetration has been achieved in Ontario. Smart meters are everywhere in Ontario. Yet, with smart meters being everywhere in Ontario, the loss in 2015 was 3.72%. While admittedly that sounds like a harmless small number, being quote-unquote only 3.72%, it's that same 3.72% that equates to an excess of $518 million in the year 2015 that was unnecessarily borne in loss by Ontarians through their rates. It's important to note that in every distribution grid basically in the world, it's understood that approximately 1 to 1.5% of all power will be lost due to the sheer physics of delivering electricity across long line expansions and via the resistance factor that will work against the electricity as well. So 1 to 1.5% is expected loss. Beyond that is loss that is identifiable and likely to be able to be remediated. In this case, approximately 60 to 70% of Ontario's loss should fall into the category of identifiable and likely to be remediated. It's from that premise that we begin to build out the business case. If we were to deploy a single phase and a polyphase intragrid sensor on the appropriate transformer assets throughout all of Ontario, the hardware investment would be approximately $483.2 million, as is depicted on this slide. If we were to deploy the necessary software to support the intragrid sensors throughout Ontario, the estimated software investment would be $16.4 million. Bringing forward the installation remediation costs, as previously mentioned, with regard to the maintenance costs of all of Ontario's distribution grid in 2015, here again we've applied the $411 million worth of cost as an estimate of what it would require, what would be required, I should say, of LDCs to install and remediate. It is important to note that installation of the GRID 2020 intragrid sensors is typically on average 5 to 10 minutes. Very fast, very rapid retrofit on the transformers, thereby lowering the deployment costs significantly. Lastly, the comms network investment required to gather information from within the grid via the intragrid sensors and communicate that back to the appropriate software platforms would require an investment of approximately $26.2 million per year. The anticipated loss reduction to be achieved by the intragrid sensor deployment in Ontario would be estimated at 50%, keeping in mind that approximately 60 to 70% of Ontario's loss today is likely to be identified and therefore likely to be remediated. So in our case, we're suggesting only 50 of the potentially available 60 to 70% that is lost inside the grid space. The carbon emissions reduction credits would equal $18.3 million per year for Ontario if we were able to achieve the 50% loss reduction as is mentioned here. The HST opportunity for Ontario would equal or exceed approximately $68.4 million, and that's being driven from the hardware of $483.2 million that would or could be manufactured in Ontario. Today, intragrid sensors are indeed manufactured in the province of Ontario. If we roll all of this information together, we are able to identify a return on investment for Ontario of approximately 3.62 years based on this information I've just shared with regard to the investment expense and the anticipated loss reduction of 50%. Against the 3.72%, again, that's being lost throughout Ontario today. Ontario's net benefit value is represented in several ways. In the form of ratepayer savings, these reductions of approximately 50% would equal $250 million per year of ratepayer savings. The anticipated lifespan of intragrid sensors is 15 years. If we were to extrapolate the ratepayer savings across the lifespan of the product, that would equal approximately $3.75 billion of ratepayer savings, again, through the year 2032. The manufacturing and jobs increase opportunity for Ontario is represented by approximately $483.2 million or more just to manufacture product in Ontario for Ontario, as is being done today. The HST revenue value is $68.4 million associated with this type of manufacturing level of $483.2 million, and there is additional HST revenue that we believe that could be realized by the province as well. The carbon emissions reduction credits would be equivalent to approximately $18.3 million per year for Ontario, yielding a cost-effective, world-leading smart grid, which is driven by Ontario's Smart Grid Fund. Important note here is that in 2014 and 2015, the Ontario Smart Grid Fund initiative partially funded a demonstration project in Ontario involving LDCs, and at the end of that experience, that demonstration project, it was concluded by the Ontario Ministry of Energy and the primary LDC involved with the project that the demonstration project involving intragrid sensors was indeed successful. Ontario's potential long-term energy program value is represented in this case by generation reduction savings of up to 2.3 terawatt hours per year, keeping in mind the Conservation First Framework Initiative includes reduction of 7 terawatt hours by the year 2020 by simply attacking the ongoing losses, albeit invisible in the past, now will not be invisible, but approaching this project in a proactive fashion, we have the opportunity to actually extract 2.3 terawatt hours annually in Ontario. As previously mentioned, carbon emissions reduction credits would equal an estimated $18.3 million per year. By deploying the intragrid sensors throughout Ontario, we would posture the grid to be prepared for DER, distributed energy resource impacts, or distributed generation impacts, depending on the terminology that you use. We also would have the opportunity to reduce up to 1.2 million metric tons of carbon dioxide emissions in Ontario on an annual basis by simply reducing 50% of the experienced losses occurring throughout the grid today. And as previously suggested, we would position the Ontario grid to be appropriately ready to embrace and handle electric vehicle charging station impacts that will indeed be burdening the grid in the near future. Conservation voltage reduction is an important practice for reducing power costs throughout the distribution grid. There are excessive voltages that may sometimes be driven throughout the distribution space that can indeed be reduced or controlled to lower costs and therefore lower demand inside the grid space. GRID 2020 began its collaboration with Dominion Voltage Incorporated, or DVI, in July of 2014. By utilizing the GRID 2020 intragrid sensor, as is represented on this slide, for a single phase in this case, the intragrid voltage information captured in an accurate and timely fashion by the intragrid sensor devices is reported to the DVI software platform known as EDGE. It is this timely information and accurate information provided by the intragrid sensors combined with the AMI or smart meter data that EDGE will extract and combine that creates the conservation voltage reduction benefits for locations such as Ontario. So in summary, GRID 2020 is designed to optimize energy efficiency, whether we're involving single-phase or polyphase transformers, pole mount or pad mount transformers. The GRID 2020 intragrid sensors deliver energy optimization and efficiency benefits. This one solution drives a growing list actually, of multiple value propositions. Each of these value propositions are legitimate. Line loss identification is certainly achieved by intragrid sensors. Conservation voltage reduction enhancement, as just mentioned, is equally available. DER or DG readiness and monitoring, which is coming straight at the Ontario grid space, and the intragrid sensors prepare the Ontario grid accordingly. Outages reduction and accelerated restoration. LDCs will have the opportunity to leverage the data value of intragrid sensors to identify poor and failing transformers in advance of outages occurring, thereby reducing the occurrence of outages and the impacts to ratepayers downstream. Additional to that, utilities and LDCs will have the opportunity to leverage outage data information from intragrid sensors to accelerate their restoration process and improve their ongoing revenue billing capabilities. We have the opportunity to reduce unplanned truck rolls by identifying failing transformers in advance of their actual failure or outage occurring. So we have the opportunity now to proactively manage assets in the grid rather than reactively managing those assets. We have the opportunity to identify technical loss within the grid, which is sometimes associated with improperly sized transformers and or improperly set taps. We have the opportunity to prepare for electric vehicle readiness and monitoring, as previously mentioned. We have the opportunity to identify improper mapping inaccuracies that may occur between meter to transformer association. That unfortunately is a relatively common situation. We have the opportunity to identify and help reconcile AMI data errors that will exist and can be, in essence, reconciled by utilizing the transformer asset upstream from the AMI meters. We have the opportunity to provide automated hands-free alert system so each intergrid sensor can be programmed and reprogrammed on the fly for specific grid tolerances and conditions, and when those tolerances are exceeded either over or under, automatic SMS text and or email alerts are provided to utility operators to notify them of the problem that's occurring within their grid, in a proactive sense, really. Premature transformer failures are averted. Pole fires and hazardous material spills would, of course, be averted. Ratepayer cost reductions can be achieved. Carbon dioxide emissions reductions can be achieved along with carbon credits. Increased jobs and tax revenue opportunity for Ontario, as previously mentioned, and increased metered revenues for LDCs can be achieved, whereby presently unmetered loss will ultimately in part be converted into metered revenues. In essence, GRID 2020 has the ability to drive powerful intergrid intelligence literally into the palm of utility operators' hands, whether it be iPhone, iPad, laptop, or any other desired medium. Information can become now readily available from the interior of the grid. The invisible is now transformed into the visible via GRID 2020, optimizing energy efficiency. In summary, GRID 2020 provides Ontario with the opportunity to accelerate energy conservation success, bend down the rate curve within the province, reduce carbon footprint and generate credit values, increase jobs at the manufacturing level and increase HST revenues, safely embrace future renewables and electric vehicles, and provide a world-leading smart grid. Thank you for your interest in how to improve energy efficiency within Ontario by leveraging the emerging technology known as intra-grid sensors, which was supported in part by funding through the Ontario Ministry of Energy's Smart Grid Fund in 2014 and 2015. Thank you very much.